Hello everyone, this is the 11th lecture of the data science series using R Python. In this lecture, the topic is logistic regression modeling. How to perform the logistic regression using R Python. Logistic regression is a statistical method used for the modeling the relationship between the dependent variable with the two possible outcomes, binary and the one or the more independent variables. It predicts the probability of the occurrence of an event using a logistic function. Common use cases include classification tasks such as a spam detection, medical diagnosis, and the credit risk prediction. Step in the logistic regression. First is the data preparation, second is the exploratory data analysis, third is the model fitting, fourth is the model evaluation, fifth is the interpretation and development. Now, first is the data preparation. In the data preparation, load and clean your dataset. Second is ensure the dependent variable is binary. Now, the third is handle missing value and the encoded categorical variables. Now the second steps in the logistic regression is exploratory data analysis (EDA). Analyze relationship between the features and the dependent variable. Checks for the multi-collinearity using variance inflation factor (VIF). Visualize the data to understand distribution and the relationship. Now the third step is model fitting. Use logistic regression libraries in R or Python. Fourth point is model evaluation. Evaluate the model using the metrics like accuracy, precision, recall, F1 score, and the area under the ROC curve AUC ROC. Next point is the interpretation and the development. Interpret model coefficient to understand the relationship between the predictor and outcomes. Now second is deploy the model in the application for the prediction. Now the second topic is how to perform the Poisson regression using RPython. Poisson regression is used to model count data and the relationship between count dependent variables and one or the more independent variables. It assumes the dependent variable follow as a Poisson distribution. Common use cases include modeling the number of events occurring in a fixed interval, such as the number of the customer arrivals or disease incidence rate. Steps in the Poisson regression is the first data preparation, exploratory data analysis (EDA), model fitting, model evaluation. Let's first the data preparation. Load and clean the dataset. Second, ensure the dependent variable represented count data. Third, handle missing values and encoded categorical. Now, second is exploratory data analysis. Check for over dispersion variance greater than the means. Second is the examine relationship between the features and the dependent variable. Third is model fitting. Use Poisson regression libraries in R or Python. Fourth is model evaluation. Assess model goodness of fit using deviance and the log likelihood values. Use metrics such as the mean absolute error (MAE) for the prediction. Key assumptions: the dependent variable follow a Poisson distribution. The mean and the variance of the dependent variable are equal. Observation are independent for each others. By following this step, logistic and the Poisson regression can be implemented effectively for a wide range of analytical tasks. Let's see the example of these both regression. The first is the logistic regression modeling. First of all, import the panda as the PD from the sklearn.model selection. Import trends test split from sklearn linear model. Import logistic regression from sklearn.metrics. Import accuracy score, confusion matrix, and classification report. In this, the first method is the sample binary classification data. Now, second is the features and the target. Third is the split data into a training and test set. Fourth is the build logistic regression. And the last is the predict and evaluate. Let's see the output of this code. These are the output of this code. Now, next is the Poisson regression. First of all, import state models as .api as sm, import numpy as np, and import pandas as pd. The first method is sample data, second is the features and the target, third is add a constant to a features, fourth is to build the Poisson regression models, and the last is print the summary. Let's see the output of this code. These are the output of this code.